Howdy, my name is Nichol and this deep project is called Touching Space with 3D Models. The main idea behind this project is creating three-dimensional models out of images taken from space telescopes like JWST in a way that allows everyone, including those with visual impairments, to experience the science behind the images and the beauty of the universe around us. There are three main reasons for color gradients used to determine the tangible patterns of each image: temperature scale and elemental composition, altitude and chemical composition, and topography. The first kind of images used were those taken of nebulae, collections of dust and gas in outer space where stars are born, or the result of a star that died, leaving a cluster of dust and gas in its place. The colors in the nebulae images correspond to the temperature differences between the gases present in the image or the elemental composition of these same gases. In the case of the image of the Carina Nebula, since it was taken with JWST's NIRCam, near-infrared camera, the colors in this image are representative of the heat characteristics of the nebula's gases. The second kind of image was JWST's infrared Jupiter. Different chemical compounds in Jupiter's belts can be detected based on the light spectrum used. These different chemical compounds and molecules emit different wavelengths of light, contributing to what we see when we observe the images of Jupiter in either a visible light scale or an infrared light scale. When observing the visible spectrum, scientists have found ammonia, methane, and hydrocarbons. When observing the infrared spectrum, scientists have detected water vapor, carbon dioxide, and phosphine. An additional cause of Jupiter's color gradient is caused by the relative difference in altitude between the so-called light belts and dark belts. The difference in altitude of each gaseous belt contains a greater or lesser presence of ammonia ice, with the light belts being higher in altitude and having more ammonia ice, and the darker belts being lower in altitude and having a thinner layer of ammonia ice. Both the presence of different chemical compounds and molecules and the difference in altitude of Jupiter's gases contribute to the color differences that we see in Jupiter's different belts. Jupiter's red spot is also easily seen in the 3D model due to its bright white hue in infrared light. The striking color differences are reflected in the 3D model as distinct parallel lines. The final kind of image used was a topographic map of Mars's Valles Marineris, a canyon on Mars that is 7 times wider, 4 times deeper, and 9 times longer than the Grand Canyon. The topographical map colorizes the image based strictly on the elevation of the landscape. Using this color gradient, we can print a 3D image that is a scaled-down model of Valles Marineris. The other main component of the composition for every 3D model, aside from their respective color gradients, is a Gaussian filter that is used in the Python code to fine-tune the model to a smoother and more preferable surface. Each image was overlaid with a Gaussian filter that would optimize the level of desired detail while not making the model too sharp to the touch. And this is how we touch space with 3D models. Thanks and gig 'em.